So we're continuing with our derivative formula here. So we've got 4x to the power of minus 9. Again, we're going to use our function x to the power of n. Gives us the derivative of n times x to the power of n minus 1. So we bring our power down. Minus 9 is going to multiply by the 4. We subtract 1 from 9. Minus 9 gives us minus 10. So it gives us minus 36x to the power of minus 10. Question 6 here, we get 5 over x to the power of 12. So we've got to be careful, because what we've got to do is we want it back in this form. To actually derive it, we need x to the power of n. We can't have the x in a fraction there. So we bring it up and say that's 5 times x to the power of minus 12. So again, we bring our minus 12 down, multiply it by 5, gives us minus 60. Subtract minus 1 from minus 12, gives us minus 13. 8x to the power of minus 1. Multiply x by 8 by minus 1 gives us minus 8. Subtract 1 from the power to give us minus 2. 6 minus 6x to the power of 6. Bring our 6 down, multiplies by minus 6. Gives us a minus 36. 6 minus 1 gives us 5. So you see we're applying this rule all the time. The 10 minus 10 multiplies by the 7 gives us minus 70. Subtract 1 gives us minus 11. 3 multiplies by 16 gives us 48. Subtract 1 gives us x squared. Again, here's where we've got to take 17 on x to the power of 18 and bring it and put it in that form. We need the x to the power of n form to derive. Now power comes down. Minus 18 times 17 gives us minus 306. Subtract 1 from the power. 15 x to the power of 8 gives us 15 x to the power of minus 8. Now we can say minus 8 times 15 gives us minus 120. Subtract 1 from the power gives us 9, minus 9. This time we got fractional powers. Works exactly the same way. X to the power of a half, bring a half down, multiply it by 5, gives us 2.5. And then we have a half minus 1. Now, this is where we, again, got to take a lot of care. We talked about making sure we know how to manipulate our indices and play with fractional powers and things like that. So we know that we've got to be really careful, because that's going to give us half minus 1 gives us minus a half. So we can leave it in that form. If you really want to, you could write it as 5 on 2 x to the power of 0.5. Or you could write it as 5 on 2 the square root of x, because x to the power of a half is the square root of x. We're quite happy any of those forms. So don't feel like you have to try and get it back into this fancy form there. So we can do it any form we like. 14, we got 2x to the power of 1/3. So again, bring our third, multiply it by 2, gives us minus 2/3. And 1/3 minus 1 would give us minus 2/3. Be really careful with your fractions. If you need to check in with your calculator, do that one. This time we got 3 times x to the square root of x. Again, we can't do our derivatives in that form. We need our x to the power of some number. And we know the square root of x can be written as x to the power of a half. So again, bring your half times 3, gives us 3 on 2. Subtract 1 from your power, gives us minus a half. Minus 7 times the square root of x to the power of 5. Well, remember our indice laws. Square root would give us the half, and we've got x to the power of 5, so it's 5 on 2. This is where our indice laws are very important. The minus 7 gets multiplied by 5 on 2, gives us minus 35 on 2. We subtract 1 from 5 on 2, which is 2.5, gives us 3 on 2, which is 1.5. Again, if you'd like to put it in that form, feel free, but you don't have to. Minus 6 square root of x cubed becomes minus 6 x to the power of 3 on 2. If you're not sure about those, you need to go back and check your indice laws. And if you're not strong with it, you need practice with your indice laws to get it into that form. So our 3 on 2 multiplies by minus 6 gives us minus 9. We subtract 1 from there, gives us x to the power of a half. 4x to the power of 6, well, because we've got two separate terms, it's okay. If they're two separate terms, we don't have to do anything except derive each term separately. So the 6 times the 4 gives us 24. Subtract 1 from the power. Minus 4 times 7 gives us minus 28. And we subtract 1 from the power. So treat each term separately. You don't have to do anything fancy there. 8 times the cube root of x would be 8x to the power of 1/3. 8 times 1/3 gives us 8 on 3. 1/3 minus 1 gives us minus 2 on 3 there. Again, do it separately. Minus 9 x to the power of minus 5. Minus 5 times minus 9 gives us 45. Minus 5 times, subtracting 1 gives us minus 6. Now be careful with this one. Okay? 1 on 4 x is the same as 1 on 4 x to the power of minus 1. Which is, because this can be written as 1/4 times 1 on x. So be careful not to make that 4x to the power of minus 1. That's a common error we see. That people just take the 4x and put it up without keeping it as a fraction as well, which you can't. It's the same as that, and x to the power 1 on x is x to the power of minus 1. So when we do that, we bring our power down, multiply it by the quarter, so that's where we get minus a quarter from. Minus 1, subtracting 1 from that gives us minus 2. This one's putting it all together. 6 on the cube root of x to the power of 8. Well, because it's a fraction, that's where we get the negative. It's x to the power of 8, and the cube root makes it a fractional power there. Minus 8 on 3 times 6 gives us minus 16. Minus 8 on 3 minus 1 will give you minus 11 on 3. And half x to the power of 3 on 2 multiplies to give us 3/4. We subtract 1 from 3 on 2 gives us a half. And 1/3 times 12 gives us a quarter, and we subtract 1 from a third, gives us minus 2 on 3. So there we go. There's how we start to apply pretty much anything in a polynomial. Now, you won't see anything else other than those. That covers all the different types of terms you're going to see. So multiple terms, so we do them separately. Fractional indices, and how do we get to fractional indices, and what do they mean? Negative indices indicating that it's a fraction. And also tricky ones where we've got the situation where our numbers are in the denominator as well, but we have to leave our numbers in the denominator and bring our x's up to be x to the power of some number. So have a look through, be really confident with all your indice laws and being able to do your multiplication and signs really well, because you don't want to don't want to muck up the question because you're doing the process of calculus correctly, but you're making simple errors with all your indices and the negatives and positives.